I'll go for. Hello, how are you?
Fine, thank you. Nice to see you.
He's busy here.
Yeah, I think almost every face is familiar to me. Who are all the owners of this department?
These are the, I think, retail market people that they are marketing.
Madam, all of you? Can I just start?
Yes, please. Definitely.
No, for photograph, you should come this time. That is his issue. No, I'm accompanied by two more directors. Come.
You are probably working here.
But we have to bring that hot thing, and that is the main. Where like Iceland or those areas where it is in the very nearby surface, it is hot. So in the half kilometer, 1 kilometer, we get 100 degrees centigrade, 160 degrees centigrade. If you go 8 kilometer, 10 kilometer, you automatically get 100 degrees centigrade. But our
So in
aim
India,
is to-
whether it is water or heat, you have to dig out to a 7 kilometers.
So, but we wanted to know 1 kilometer or 1.5 kilometer, 2 kilometer maximum, we can get 100 or 200.
Okay.
So, and thing is that if there is a hot thing, so there will be water coming by the recharge mainly, and then it gets heated and come up. And that is the hot spring, what we get in many places at the manifestation. So, and another thing in the geothermal energy, another main important thing is that it is 24/7 and 365 days in all the places wherever we can dig it. Like that, and there are many other things which is not in other renewable energy, like it can directly use for the space heating, it can use for the agriculture drying, methanol production, snow melting, not in our country of course, and then hydrogen production. Like that, there are many other uses other than energy production, and it is the top countries, 10 countries where they are already producing, and but in India our scenario is 8 still now production of energy. And but we have the potential. So last 30-40 years, CSI, NGRI, ONGC, and many other institutes, they have worked and we found that these boxes, what we can see, those are the area there is more than 50 degrees centigrade and it goes up to 100 degrees centigrade. So maximum temperature in Taktapani in the city India goes up to 100 degree. Recently we measured 150 also. So like that.
How will you tap that energy?
Yeah, so tap that energy mainly is that when it is coming out. So if it is more than 100 degrees centigrade, it comes steam. So
You mean side also?
Because your PPD says answer to that.
Yes, sir.
exploitation of the energy and then sustainable utilization of the geothermal resources. So, why center is necessary? National Geothermal Research Facility, and in NGRI, under one umbrella, we have all the facility whatever required for the geothermal energy exploration, and that will provide the scientific support for the exploitation for the other industry, and then it will be sustainable utilization of the geothermal resources. That also we can provide the solution for the sustainable energy production. Like hydropower, solar power, so it will run the turbine.
Turbine is
It will
required.
run
No?
the turbine, yes. But we will tell madam where it is sustainable.
No, I understand. But what I'm asking is, if it is a hydrothermal station, only we have a kind of a water reservoir, and then you will have all the turbines. And if we have a very systematic and a stipulated flow, and then you will make reactions to happen.
Magma means it is very hot. Then it is very easy that water will go touch in the magma or in nearby magma. In this scenario, most of the water come by fracture and fault zone. And then due to season, there will be hot. It is not magma, but there will be hot. and then water became hot water, not spring water. So what we want to do, we have to do as scientific progress is happening. Now in one borehole also we can do. So but we need one borehole for the deep. And
All those points I understood.
If the pressure is good enough, it is accepting question. So the hot water will comes out maybe 30-40 degrees Celsius temperature, and that hot water is coming at 70 degree, 80 degree, 90 degree, 20 degree. And when it comes in contact with the hot water, it gets vaporized, and that vapor is passed through a turbine system, is kept outside. It goes in so force the turbine gets rotated. It produces.
So meaning is the stakeholder who are you identifying, you have to get it installed over there, so that you have to channelize this flow that goes into the cycle.
that happens when it is less than 100 degrees. When it is more than 100 degrees centigrade, it is automatically it is already vapor. When it is less than 100 degrees centigrade, then it
That study you also have to do, sustainability study for the each.
No, she was telling me it is 24/7 and not very well.
thing is there by which it is getting heated and coming out. So something is there.
Norway is producing.
Any other
Madam, other than application, I had one. And that itself is a success. Number two, then you have to channelize it in such a way that the turbine is everything is in the water, whether you will get it at the same speed. So it's a kind of a kinetic energy as well as some amount of internal energy. So internal energy is also.
India, I told there are 10 provinces already being identified. So that is one thing.
From the
From the geothermal area, many people, many outside countries are going. And not only methanol, there are many other things. Helium, then fluoride, they can use it. No, methanol not from water, madam. In those areas where geothermal thing is there, so there whole area we get methane gas.
So you mean to say instead of water that itself will be methanol?
Methanol will also come, not only
So we have
methanol.
to separate it out from
Yes, yes.
Therefore it is methanol extraction, not
Yes.
production. It should be the
Yeah,
methanol extraction.
Yes.
It should be extraction.
Like in the compressor, helium is coming out. So it depends. And in the Kuga, it is sulfur is low. So now when this is doing the borehole and here, then Managuru is in here only, Telangana, and then Tattapani is central India. So what we can see in the first one, we can see that is borehole actually, not hot spring. In the borehole, it is continuous water is coming out from last 30 years, not 85%, continuously. GSI, we measure interval many times and we got it egg, it is boiled. So we like that second one, and third one is Managuru, Telangana. So here also people have started trying to extract energy. 20 kilowatt CSIR has put a thing, but it is not working now. But they are trying for the geothermal energy. And fourth one is the, you can see this is also one borehole. This is also not hot spring, and that borehole is generally that heat flows. And sometimes if it is open, it is continuously comes like that. Here only I told you it got 103 degrees centigrade in the month of the March. This year we measured. Last year we measured it was 98 degrees centigrade. So these are
So global warming is that.
You can take other applications like space heating.
yeah. So space heating also we can do mainly in the Himalayan area. We have to now narrow down the area. Like whole central India we cannot do. So where we have to do, and then even if we do like example Tattapani, we have knowledge that Tattapani we have potential. We can gap. So there is a gap between the research till now and for industry to use it. So that gap we wanted to India has taken initiative. NITI also we are work on that. So and then we have done in the 1 week 1 lab that we have pictures of some game and we suggested that now India so while India right the center
Something under ANR or this one?
No, still not.
Such explorations, do they give funding? They are now coming up with a hub and spoke model based provisions. No, I did not.
So people who applied are, I think,
Outside.
outside.
Oh, they are outstanding. Okay, carry on.
so and then what are the capabilities? So these are the capabilities in GRI. We have laboratory facilities of all this. So geology, hydrogeochemistry, rock mechanics, different type of resistivity study, then seismic study, then gravity mechanics.
Tatapani is remote, yes. From 4-5 hours from
Raipur, it is 4
From Ranchi,
kilometers.
it takes 6 hours. 6 to 7 hours from Ranchi. From Varanasi also.
Varanasi, now what we made so far, we can see here that this is up to, there is a probability of hot thing inside. So
But
up
now
to
no,
300,
we have not invasive
up to 500.
results, which can see up to 5 kilometer image.
Don't make it as an open source.
Yes.
Does the seismic signal give some idea?
These provinces are identified on the basis of CSIR and GRI. What we are doing basically, so as I told, we have all the recent years, so we are doing mainly all the studies and then trying to reserve as interesting. So its temperature, its shape, other than magma, what can be, so it is mainly recharge. So we recharge and we can give for the site selection for the exploratory drilling. That we cannot do, but we can suggest the industry for this one, and then feasibility assessment for setting up the power plant. And other geothermal residual also we can provide the data. And what is we are doing for the Tatapani? So this is the Tatapani hot spring what we are seeing, and if we see there are lots of hot spring here in this area.
Ministry is not looking for.
And then you can start giving a kind of a training. That if these are input for AI and you start giving some kind of a training. But for which you have to
Reliance oil, like that.
Reliance is
EPC
okay.
oil.
They approached us.
So they are telling us to do the MOU, to do the work, because they will give the tender and we cannot take the tender. So they came actually in this in 2 months back. The board's data, temperature data, everything they wanted to share us. And,
they will share with you.
but for publication, they are telling
Not
that
very clear. That's why it is a hold position. Not called.
they know not gone, but
No, will they share their data with you?
That's what they said, but one of the
CR
person.
means they will give the samples that the money should be taken as a priority, and then we have done brainstorming session and then the intelligence sub came. So here also they have recommended many things and
Here, people are from all the boards,
yes.
all the heads of different
Yes.
institutes. They are not.
ONGC, oil and EPC.
Madam, just with regard to your question, application of AI for the geothermal reservoir, Bhadrasa is also here. Sir, if we have three-dimensional seismic data on the surface and want to know what is the 3D architecture of the geothermal reservoir in the subsurface, we can take help of the AIME because the large volume of the data, 3D data, we cannot process and interpret manually. To reduce the human intervention and to get the first decision to the industrialist, we need to have a quick outcome. And that one based on the attribute computation, we can understand. If we like to know the three-dimensional architecture or configuration of the subsurface geothermal reservoir from the 3D surface data, it is only the artificial intelligence and machine.
For which we need the first-hand data. So that data should go from your end. Whatever you have as a primary data, that should be shared with him. So let him just make it as to be Indian AI, this is general AI. So he has some general knowledge about that.
Actually, madam, ये electrical range shooting this is a special kind of measurement required, and not only magnitude but directionality. So, like fracture, pathways, those kind of directional feature can be available only with engineering. And this was created actually in one of the LC paper.
Why nobody else is having all these things?
Expertise is not there.
Yeah.
How did you get the expertise?
These are in a long run, slowly we can.
So like earlier there was a standard electrical ratio to move that. You send the current, you set up the chemical into the measure the potential, and we'll make movement and make information and investigation in different level. But now it is providing a 3D with directional thing. So like we have been measuring potential between two electrons. We are putting it in orthogonal fashion. So you measure potential difference here, and then depending upon the ratio, we get the directional. So that's how it is a different, and the way of processing also little different. Like we take the empty data, so it is all GPS synchronized.
Case where GPS is denied, what will you do? Denied.
GPS. No, madam. This is for GPS synchronized.
No, a situation will come, I am telling you.
For positioning. For positioning.
Honestly, now you did not get.
It can work.
It is.
Yeah, because it has internal clock. Yeah. No,
No,
it's
it is-
GPS dependent also, but it has internal clock also.
Oh, okay.
So it will manage because we need time
That
step.
internal clock and the GPS, what is the correction factor? No correction factor?
What happens when we go to field? Before going to field, we open it and try to synchronize it with the GPS. Then there will be a time. So there will
This is
be
what
no
I
time.
asked. Therefore, you do, this is a kind of a manual synchronized.
But I think he and some authors have developed this technique. What they say, directional.
All group develop this technique.
Everyone has published.
It is an electrical field vector ratio imaging. So it is a little different than conventional way. So right now sending the current not only from two directions but multiple directions. So the current is passed through different directions. So we get a
However, it will be useful in urban setup, it will be more useful.
Unfortunately, he has published that one before making ICR.
Yeah, that was
Why did
the.
you allow me to happen?
Before we were not aware because I was just
it's based on the publication.
That method is not.
Please, yes. Had I been in his position also, I would have published at least minimum 2-3 papers. Because no, he wants to really make some kind of a gain out of it. No? So you as a director, then you have to identify if at all something is totally new, you should enter in how to check it up first.
In Tatapani also.
This was to publish more here. That is the.
No. What I'm asking is, if at all it is not to be published, how will you give him some kind of an encouragement? What will he do with that finding? Which I'm asking.
Yeah, IPR is the next one.
IPR also he can do?
Yes.
The concern is methodological development only. Because it's a unique kind. It was not existing anywhere. Then we
This has got a unique application. But suppose you want to know about whether the trans, whether it is paleo river or any destructive thing or it can damage.
Network of water.
So you can see here, I mean, positioning of the transmitter receiver can be done in such a way. It deals with the
He is worried about landslide.
Landslide. Not at all for biological body. Biological body, how much?
But where people are not able to penetrate through. Therefore, with this kind of an, this is what he is asking Bariel. He is talking about at a depth.
But for that, GPR is the best tool because you get very fast. It takes little time, but GPR.
Not only 1 to 2 kilometers, you can go up to 30 to 40 kilometers. You have precise image of the subsurface. Here, just you see on thermal observers, this is not done by us. This is done by outside. But India, first time we are doing the seismic study for geothermal studies. Detonators and everything, so we are blasting it, and after blasting, this is the blasting we are getting, just like your it will create, yes, to make a mechanical vibration to the subsurface.
Artificial.
Yes, and this artificial. No. It is controlled source. That's why. But just simple ground source will not be really. No, so we cannot put that much of there.
It will come as a noise, and you have to remove that.
But that is also not precise. But if you use the explosive, it will be the precise image of the subsurface, depending on our target of interest.
Why did it take this many takes now?
No, it's a walking. And if the signal is this signal is more than your walking, then see.
The amplitude should be.
These are the lines.
This is what frequency?
100.
So here we can capture the frequency.
Good evening. These are natural processes. These are two instruments. This is gravimeter and that is magnetometer. We used to measure the local field gravity and magnetic of the earth. Then we will get the, suppose this is the area, we will take the instruments. We are having, engineer is having series of instruments. This is the latest one, CGER autograph. So we will go there, we will measure gravity, magnetic, and along with for accuracy, we use DGPS. So with this, we will measure different like bases and stations, and after that we will process it, and we will get two types of maps. So one is magnetic and second one is gravity. With this, we can find what are the major faults and major lineaments in this region, and also lithological contacts. Suppose in this Tatapani, this is Gondwana sediments and this is granitic. So we will get a clear distinction, and also we will get subsurface. We can easily identify different types of contacts at different depths.
From where water is coming, the structure of the road.
This is the region.
But these are all qualitative or quantitative?
Mostly qualitative.
What I'm asking is
That instrument will be result.
you can just say that this is the area. You can
Yeah.
only after you just process it.
Good evening. This is the hydrogeochemistry of geothermal water. Here we can characterize the chemically in terms of major ions and cations and trace elements RE, and also we'll measure the isotopes. Rare earth elements. Because to understand the water rock interaction, rare earth elements will give the information whether the source rock.
No, these are all analytical equipment.
Yeah.
I'm aware of that.
Yes, yes.
Specific heat capacity, density, porosity, fluid velocity, radiogenic heat production, geothermal. Yes, sir. So now we have a different instrument for measuring thermal conductivity at ambient temperature, also at elevated temperature, which is 100 degrees Celsius. So one of the thermal conductivity we are showing here, where we can measure thermal conductivity with any irregular shape of the cells. So we can measure directly for taken from the proteins. We can measure. Even we can measure this type of stones. So we are generally measuring the thermal conductivity for particular rock samples like linear rocks, rocks. And
From this thermal conductivity, what will you infer?
mainly we are estimating the heat flow. For that we need two parameters, geothermal gradient and thermal conductivity. Geothermal gradient, we are measuring temperature in the boreholes, and we are calculating geothermal gradient from that, and we are measuring thermal conductivity in the laboratory. So product of these two parameters, we are estimating the heat flow density. That is the basic parameter of thermal conductivity. So that is the starting parameter.
I understand.
Like this we get
So at first instance, we cannot do a decode. So we fill sharp or see final.
UTA I have seen in other labs also, universal testing.
Here we can understand the real field conditions which is required. So for that we will have all these mechanical problems which we have.
What is this rock related understanding you also like?
Yes.
Geothermal
because of the other accident.
By drilling, it will be very important to know the strength of
Yes,
the
very
surrounding.
important.
We have to give to you something.
What is that?
This is called pain they have substituted. Please come.
Already you gave me one pen. You want me to write more?
This is from our.
You are giving me the pen and taking my notes. Thanks all of you. Wish you all the very best.
Small actually called me about GPR. So the problem with the BSF is what they want is once we run the GPR, if there is a tunnel, there should be a sign or some sound kind of thing that is tunnel. But we are actually analyzing the electromagnetic property. So based on the shape of it, it could be tunnel of A type, B type, C type, or collapsed tunnel. So we need large amount of data. Once we have enough data, then we can generate some AI. So this is what we suggested them. But they said,
you're talking about
BRO and BSF as well. But then afterward they said, no, we go to the private, we'll explore the private.
Can you just extrapolate it to understand the tunnel dynamics
inside? Exactly. But at the border, last time when they went for the demo,
the Pakistani effect will come very rarely.
Yeah.
No, what I'm saying is whatever they are doing, like the way Patra said, it's a beautiful idea. Patra suggested a very beautiful idea. So you can just take all these inputs and you can just make your, I would say, scavenger to learn all these data. Then you send the scavenger inside. Then you get to know the inner dynamics.
Only right now.
Get more money.
Yeah.
But you should now identify a strategy. I'm this Viva by sitting in recordation, you will be able to talk very technically. You will be able to impress upon the people on technical grounds. Whereas you guys, like your director, or working people like you, or him, or ABC, you people should go and meet with whether they have different designations. Talk to the people and make them understand that first they should believe you, they should trust you.
This is our sway.
Yeah, I think I have seen you. Okay, thanks all of you. Thank you, man. Thank you. I'll see you sometime. Oh, sure. Thank you. We had close to discussion.
Actually, one thing I want to say is, madam, this is energy building. Where the top floor is gas.
Yes,